Hey, what's up guys? I'm Ashwini Gupta
My name is Avinash.
and today we are at MS Ramayan Institute of Technology.
Today we are going to give a tutorial on R with Hadoop.
And for this video we are installing R and R Studio. R Studio is an open IDE integrated development environment for R.
And R is a programming language for statistical computing and graphics.
And R Studio is available in two editors. One is the desktop version and the other is the server version. So we are going to do it on the desktop version.
R Studio is written in C++ programming language and uses Qt framework for its graphical user interface.
And now coming back to R, R was developed by Hoshelka and Robert Gentleman at University of Auckland, New Zealand, and it is currently developed by the R development core team.
R is widely used among statisticians and data miners for developing statistical software and data analysis.
And now talking about Hadoop. Hadoop is an open source software project that enables distributed processing of large data sets across clusters of commodity servers, and it is written in Java programming language.
It is designed to scale up from say, a single server to thousands of machines with a very high degree of fault tolerance. And finally, we'll integrate R with Hadoop in our video.
And now you have to fire up your laptop and start Ubuntu and follow our instructions. Hey everybody, welcome to this tutorial where I'm gonna show how to install R and R Studio. For installing R Studio, you first have to install R, and to install R you have to go to your Ubuntu Software Center, where on the search tab on the right top corner you have to search for RBase, and when you search RBase you're gonna click on the first one that pops up. Click on the more info, and there you'll see you have the R for download, and then you click on install, and it's gonna take a while, and this will be the password for your Ubuntu Software Center, and there you're gonna feed your password and authenticated, and R will be downloading. You can see R installing in your system. Yeah, so it's gonna take a while to download. So you go to the progress bar, and then you see there's 47.3 MB of downloads, and whenever you have done it, you just go to your terminal and press capital R and then hit enter, and then you're gonna see the version of the R, and you can see R is running. So there's you have downloaded R and you can run R, and here I'm just going to show you some demo commands in R. For example, you can just plot a simple graph by entering this command. Yeah, so you can see you have a graph for the entered data, whatever data you have entered. This is just a very small example of R, and then you press Q, open and close brackets, and then press N, and you can just exit from R. Yeah, so this is it, how to install R. After installing R, you can install R Studio. To install R Studio, you need to open your browser, and you go to rstudio.org. You go to your search bar and then search for rstudio.org, and you can see there wide open, it will be the website of R Studio, from where you can download R Studio, and then you'll have the link to download R Studio. You just press that, and there you'll have two versions of R Studio. One is the desktop version and another is the server version. You do not have to download the server version. you go to the desktop version and hit download, and there will be on the right hand side there will be a demo or studio video that will tell you about the art overview and other features. So you can play that video and watch it. I think that will be beneficial for you if you're using R and Art Studio for the first time. And that's going to teach you how to use Art Studio properly. And you come back and then download the desktop version. You click on the desktop and then click on download Art Studio desktop, the free version. And if you go a little down below, you'll see installers for supported platforms. So you're gonna see a bunch of downloads available here. You have to select your operating system and what bit operating system you're running. For here example, I'm running an Ubuntu and my system is 64-bit. So I'm gonna click on the fourth link and you just select whichever one is yours, and then you select the path where you want to download it and then click on save. So it's not a big file, it's a small file, so it's just gonna to take a while to download, and then you just leave it to download. Yeah, and so you click wherever it's downloaded, showing the folder, go there. Do not open it, just right click on it and open with Ubuntu Software Center. That's gonna again open your software center, and then from there you can install Art Studio. Yeah, it's like that. So the Art Studio page will open and you just have to click install, which will be on your right hand top corner. So just press install. And it'll take some time to download and install our studio again. Yeah, and there's again that authentication thing from Ubuntu Software Center where you enter your Ubuntu Software Center password, and in the progress bar you can see the changes are being applied. It's gonna take a while and you just wait until there. And then you go to the search, and then when it is over you go to the search and then search for Art Studio, and then you'll see a blue ball where R is written in caps, and then you click that, and yeah, that's there, Art Studio running on your system. And yeah, and then you'll see Art Studio pop up on your screen, and Art Studio will be mainly of three sections. The one on the left hand side will be console, the one on the right hand side top corner will be environment and history, the one on the right hand side bottom corner will be file, plots, packages, helps, and viewer. On the console you can type the codes and you can see the inputs on the environment section where the values for the variables will be displayed. In the history you can get the set of the commands which you are entering in your console, so you can keep a track of what you're giving the input. And in the console, if you press the command getwd, will show you your working directory. And in the package section where you go, you will see a lot of packages available there. All packages are important for their specific tasks, and if you want to perform certain operation, for example you want to plot some specific graphs, you need ggplot2, and several other packages. So packages are important, and you can download the packages from the packages tab available there. And if you press the command plot y, it's gonna plot the graph for y, and you can view it in the plot section. And in the help menu, you can go and get help in any topic in R, and you can run another script where you can type a code in our program and you can run a program in our studio. So this is it, how to install R and R Studio.
Segment we are going to view different type of R data structures. There are 5 type of R data structures, namely vector, matrix, array, and the data frame and list. We are going to view vector first, and it is declared using this command. Vector are one-dimensional arrays that can hold numeric data, character data, or logical data. In this example, we are viewing that numeric data. We can access it using this command. Suppose we want third element of that array, then we can use this one. If we want first, third, and fifth element, then we have to use this command. And we can use a colon operator to generate a sequence of numbers as shown. Now we are going to define matrix data structure. Matrix is a two-dimensional array where each element has the same mode, that is numeric, character, or logical. Matrix are created with matrix function. Now we are going to define the vectors, cell vector which it should contain. We are going to define the row names and column names, that is R1 and R2. We are going to define a 2 by 2 matrix here, that is it should contain the 2 row and 2 column. Yeah, we have defined the name using a character vector, that is R names and C names. And we are going to define the my matrix. We are going to define that my matrix. We enter the cell vector here, then number, we define the dimensions, that is number of row equal to 2, number of column equal to 2. And then we are defining how should it access the cell vector, that is by row or by column. We are going to use by row, that is equal to true. Then we are going to access the names, row names and column names here for our matrix. Yeah, we can access our created matrix using this command. Yeah, as you can see here. Now if we want by column, if you want our matrix by column, then we can use my matrix by row equal to false. Yeah, you can see the pattern, different pattern from previous one, and we can match that cell vector also from here. Now we want to generate another matrix X, and we will use a colon operator for generating the sequence. and we are creating number of row equal to 2, and by default we'll get the cells by row only. Yeah, we can see here it's by row. Now we are going to define arrays. Arrays are similar to matrices but can have more than two dimensions. They are created with a array function, an array function. We are going to create the dimension name, that is first. In first dimension we will have a1 and a2, and then in second b1 and b2. Dimension name is the optional list of the dimension levels. So you can see here, dimension is a numeric vector giving the maximal index for each dimension. Now we are going to create that array using this one, and we are going to generate a series of numbers using colon operator 1 to 24. Then we are going to access that dimension list, which contains the dimension labels. Oh yeah, we have wrote the incorrect command. We have missed the hyphen here. Yeah, now it's right. Now we can access that as you can see here. Now we are going to define data frames. Data frame is more general than matrix in that different column can have different modes of data, that is numeric, character or logical. Data frames are most common data structure you will deal in R. Data frame is created with data.frame function. Here we are going to define the column names that are namely patient ID, age, then their disease type and their status. You can see here. These are the column names: patient ID, age, diabetes, and we are defining the contents of each column. Here we can see that patient ID and age are numeric vector, and diabetes and status are character vector. Thus we define the column diabetes. Yeah, we wrote the incorrect code. Yeah, now it's okay. Now we are going to define the data frame, and data frame name is data, and we are going to use data.frame function. Okay. We got an error. We have defined that patient ID wrongly. Yeah, we did a spelling mistake, but it's okay. Yeah, got that data frame here. You can see it's a matrix, but can have different modes of data. Now we want to access only second and third column, then we can use this function. I'm going to show you different types of methods from which we can access this data frame. Now I am going to show you list data structure. A list is a ordered collection of objects. A list allows you to gather a variety of objects under one name. For example, a list may contain combination of vectors, matrices, data frames, and even other list also. You can create a list using list function. Here we are going to define the objects our list should contain. First we define the G object, which contains a character data. Then we define a H vector. Then we are going to define J as a matrix. Now we are going to define K as a character data. Now we can define our list as follow. We are using list function here. Then we are going to find the different type of objects, and we are also naming the objects in the list, that is title and age for our G vector and H vector. Now we are going to access our list. In this way we can access our list. If you want to access only second row, then you can we can use this command. Second column, sorry. Now we want to access our edge object, then we can use this command. Yeah, that's all for this video.
Hey, what's up guys? In this tutorial, we're gonna see the cars dataset in our studio. For this, you go to the console and press question mark datasets, and you will see in the help section the details about the datasets. And in another code, when you press library and in the brackets you press help is equal to in the code datasets, in the main part you will see the details about all the datasets available. This is information on the package datasets, all the description and all the index. And when you hit question mark library, it's in the help section, it's going to show you the details about the library. And then when you hit just data and in the braces nothing, it will show you all the data that are available by default in our studio, which you can use for your learning purposes and to plot various graphs and see how the graphs come out. They have a lot of data sets, and in this video we'll be using the cars data set. They'll be having the speed and the stopping distance of the cars. And there are another bunch of data sets available which you can use. So you just press question mark cars, and in the help section you can see the description, the usage, the format, and some examples which you can implement on the cards dataset. And when you press question mark str, it's going to show you the structure of an arbitrary R, where you can see a lot of arguments, how to use them, and again a set of examples which will be useful to you. And then when you press str cars, it's going to show you the speed and the distances, some 50 observations of two variables. And when you press fix cars and hit the enter, then you can get the R data editor. In the data editor you have the default values of the speed and the distance of the car data set, but you can go there and manually edit each and every data. You can change as per as required whatever you need, and you can save that, and once you're done you just quit it, and then you have finally edited the cards data set. When you go for str and scom, you will see 11th observation of 8 variables. You can see it highlighted there. And then when you press the command view and scom in capital V, view with a capital V, you can see in the main section 11 observations of 8 variables. And then again you go to question mark cards in the console and hit enter, and we already saw that there were a couple of examples there. So now we are going to copy the examples from help and then paste it into our console and try to run it and see what are the graphs we get, what are the plots we have. So with this we require the stats and require the graphics. These are the required things, and we are going to plot a graph of cars with the x-axis as miles per hour and the y-axis as stopping distances in feet, and in the lines we have the color red and the other parameters. The title will be cars data, and then we'll be plotting the graph cars again with the same description and parameters, and in the title it will be main cars data with logarithmic scales, and you have the lines, the summary, and the operators you have to use, and the plot fm1 will actually plot the graph in the plot section, and when you hit enter, there you have the graphs. You have 4 graphs: residual versus fitted, normal QQ, scale location, and residual versus leverage. And then we will go and try out the another example that is present in the help section. You can go to the help section by pressing question mark cards, and we copy the second example, an example of polynomial regression. We copy it from the help section and paste it into our console. And as we can see, this example will provide us the graph between the stopping distance and the speed. And when you run the command plot fm1, which will show you the individual graphs out of the 4 graphs, and when pressing return again and again, you will see the different graphs one by one, so you have a better view. So this is cars dataset and various operations on cars dataset.
In this segment of video, we are going to see different types of graphs which are predefined in our studio. We are attaching our empty car data sets which is predefined in this R studio, which we studied earlier. We are plotting graphs between weight and miles per gallon of the car data sets. We want abstract line between that weight and mpg, then we can use this command. Now we want the title for our graph, then you can use title command, and we'll define in as regression of mpg on weight. Yeah, you can see here the title. Now we want histogram for the same empty cars, then we can use this command. We got an error. Yeah, we have to write for what, that is for miles per gallon. We can see here frequency versus miles per gallon graph for all the cars. We can define number of brakes for that x-axis, that is miles per gallon, and we can select color also. Yeah, we got an error. We have to write brakes here. Yeah, now it's right. You can see here we got a red colored histogram for empty cars. Now for the same data sets, if we want to define the x level, that is a level for x axis, then you can use this command. We are defining 10 breaks for our x axis. Column, yeah, color is red. And level for axis is mile per second. And the title is histogram with normal curve. Yeah, you can see here histogram with normal curve. The title and x level is miles per gallon, and there are 10 breaks for this graph. Now we are going to define x feet and y feet as shown here. We are using different function here for this needs. We got an error. Yeah, that would be correct. If we want to create a line, then we will use x feet, y feet. We change the y feet a little bit as shown earlier. Yeah, we got a line, and it's showing the mean miles per gallon. We can see that between 20 miles per gallon it is maximum. We are getting maximum frequency. Now we are going to plot a density graph. Here also we can see that at 20 we are getting the maximum density. Now if you want a color for this density graph, then we can use this command in our function polygon. Yeah, you can see here. We got blue color, and you can see border color is red here. Now we on dot chart for our function, then our empty card dataset, then we can use this command as dot chart for dot chart. Yeah, we wrote something wrong. Yeah. Now we wrote something wrong. Yeah. Now it's okay. Yeah. We have to write these commands. Now we can use, we can see stack bar chart using this function as shown. If we want bar plot, then we can use this one. You can see here different types of data. We are seeing pie chart here. That is pie chart with percentage. Now we want a 3D pie chart, then we can use it as it is. You got a scatter pie chart. Yeah, that's all. We are going to install a Hadoop. We'll use that update command, sudo update, and we'll enter the password. Now we are gonna use install command, and this is the command we can write.
Sudo apt-get install jdk. That is the command which you have to press into your console and press enter key, and then you can see the done commands and the debian packages are being added.
Now we have to check the version of Java.
As you can see, it's rocking a Java version 1.7.05.
Now we are going to install SSH.
Sudo apt-get install SSH, and it will be reading your packages, and you can see the meter bar will be going on, and is the processor triggers will be on 2.1.0.
Now we are going to install rsync.
And then there's a password which you have set for your system that you're gonna feed into it, and then it's gonna get done, and the packages are gonna be updated.
Now we are going to use that SSH command for generating key.
SSH keygen T DSA P and F. Yeah, that's the command there. And also you have to feed the path name, I guess, .ssh/id/_DSA, and then you will see the random image is going to pop up on your screen. That will be your digital print or something like that.
That's the encrypted key for you. And that is DSA command, DSA key, and Now we are going to use this command cat uh, slash dot ssh dot slash id esa dot pub, and we are going to authorize from that command authorize keys.
You don't need to worry about these commands. We'll leave a link in the description below, or you can just copy and paste these commands.
Now
And then you have to go to your internet browser, open the search.
yeah, and we are going to download Hadoop. That is, we are going to download in this second video. We are going to download Hadoop 2.6.0.
And just go to hadoop.apache.org, and then you have to download the latest one if you want to download the latest one, and select download the release now, and select the Apache mirror, and you go to the current directory and then select the tar.gz file.
tar.gz file is for Windows, is for Ubuntu.
And then when it's the download is going to get done, and then you run this command.
We are going to use that wget command for downloading that that file. Yeah, it's showing how what we are going to whatever we are downloaded, we are going to see that. Now we are going to extract that file Hadoop file. And we are going to extract the for that Hadoop.gz file on the desktop, and we are moving to our desktop.
And you just follow these instructions and copy the codes, and then it's going to lead you, and you walk you through the steps. It's gonna take a while, so you just have to be patient and just copy the correct codes into your console and just run it.
Now we are going to extract that tar.gz file. We wrote, I think, wrong code. Yeah, that was missing one. ZX, that ZXBF. Now it's been extracted here. As you can see on your desktop, we have a folder named Hadoop 2.6.0. And now we are moving that folder to user/local slash Hadoop folder. Now we are going to use this command, and we
update alternatives config Java, but we are getting some error. Hope you have to fix that.
we missed that hyphen. We copied the path here. And we are going to open that gedit window. Yeah, we are getting this window,
And as you can see in the shell, the script is right there.
we are going to write this command,
And then you can see what you have to do. Just like highlight it and click on copy, and paste it here on your console.
Now we are going to use gedit command to open file from this path which we are typing. Yeah, this command open this window. And we have to edit this command export java home, and we have to enter the path which you copied earlier. Now we have set the source, and we are moving towards the that location user local Hadoop bin, and then I think no, it's wrong. We have to enter at a yeah, etc then Hadoop. Yeah, we move to that folder where we moved that Hadoop 2.6.0 folder. Now we open this window. We are editing the configuration here as shown. We are opening this window. Yeah, we edited as shown. Now we are going to copy this file to the another location, that is mapred site xml.xml, and now we are going to open that file which you have created earlier, that is mapred site.xml. Yeah. Now we are going to make a directory in user slash local slash Hadoop data slash hdfs slash name node. We wrote the incorrect command. We have to write mkdir for making directory. And now we also make a data node too. Name node is handled by master slave, and data node is handled by what is that called, master and slave node. See, we open the file, copy.
and then you use the command sudo chown and whatever is your username. In this case we just have a demo name, but I guess you can use yours.
We enter the wrong data, I think. Wrong command. We are going to set source and
The HDFS name node format, but it is giving some error message.
now it's working.
You press Y to proceed.
Now we are going to start all Hadoop nodes. Yeah. We'll enter yes.
And yes again. And then you go to your browser and open a new tab. And the search bar, you have to search for localhost colon 50070.
It can show that we have started the Hadoop server there, and yeah, we can see that we have successfully started that Hadoop server, and we can see how name node information we can get from here. Yeah. These are the contents of that name node name node. Now we are going to see data node information. Yeah. These are the windows you can see. Yeah, it's showing all application of Hadoop. You have to use that address as shown in the browser.
In the address bar.
Yeah.
And we just follow the codes which we are entering into our terminal. As you can see in the desktop, a folder name data just popped up.
Yeah, we made created that directory here. And we can see the contents of this test file.txt, which we created using that Hadoop command JPS. It contains that name node, data node, resource manager, and all.
And again, simply just have to be patient and keep entering the codes. Yeah, it takes time, but if you enter the correct code and follow these instructions, you can run it successfully.
It's showing some warning. But warning doesn't matter. Now we are going to integrate that file, input that file test file.txt as an input file to Hadoop or a Hadoop file system. Now we will open browser and browse the file system, and we can get
You can see the permission, the owner, group name, size,
you can get that
application.
input file here. Now we are going to use this Java command, this one, for creating a output file. It's been successfully created. That what kind of output file? Our job is running on Hadoop. Yeah. We can see total job counters are 4, which are as shown here. Now we are going to see the contents of that output file.
We have to edit this one, make the changes, and come back to the terminal. Now we are going to again execute the same command with these changes. Now it's showing all the input paths and number of splits, all the things, and hence we have installed the Hadoop, and the MapReduce is working.
Now finally we are going to integrate our R with Hadoop. We'll use that super user, Hadoop user. We'll enter the password, and now we'll choose the folder where we have stored our Hive. We choose that folder. Now original data will be. Now we want employee data. We have created one data, and these are the data here. Now we have activated data, and we want to show the tables, and here we have created table which is our imp, and it has following following attributes: employee name, e-name, job, mgr, and hire date, which all are string, and salary command are integers. Now we are using that select command, select star from imp. It's showing this data. Now we are creating this Hive. Now we are activating the Hive server. It's been started. And showing error. Now we'll start Audio Studio. We have started the server, and it's showing here sign into Audio Studio, and this one. Yeah, we opened the Audio Studio, and here we have inserted that command in console rhive.init, and in history we can see that install package rjava rserve. Yeah, it's been installed by our Hive, and we can see install our Hive, that package tar.gz, and it's been built. Library R Hive. It's showing like this one hive home equal to user local hive. It's we can see here.
And the basic idea is I'm going to issue our Hive library, and I'm going to need the connection with a few details. So our Hive home, and where my Hive is, and where my Hadoop is. So I'm gonna set these variables, and it reads some details from my machine. You can see that it reads the location of all the libraries, and then I'm gonna collect with the Hive server 2 equals to false. That means I'm gonna be using the original Hive server, and it does the connection. And now my R is essentially talking to my Hive in the background, which is on top of my Hadoop. And you can see it's okay, and we have started. And if I go back to the Art Studio, I can start doing little queries, like I'm gonna select the salary from them, employee, and I'm just gonna select the salary, and I'm gonna put that into the variable called sal. And what happens now is just it does the execution in the background. You can see it is actually running the MacReduce job, talking to my Hadoop cluster, getting that information, and returning the result. If I now look at the cell, there are many salaries in the table. And it is summary sal. And now we can start using the function inside R. And now if you see the salaries, we can see the minimum, the maximum, and other datas. And the other things which I can do is like I can draw a pie chart. And you can just type in the console pi table cell, and you just hit the enter key, and you'll get a plot which will show something like this. You can really start drawing some graphs out of the data from your data or some custom datas. And now we'll use asterisk to select all the data and pull it in all variable, and there it is. And when you use the summary all, you can see all the data. You can see all the employee numbers, to analysis, to clerks, some managers, the president, the salesmen, and some minimum salary, the maximum salaries, the commissions, the zeros. Yeah. And now I can really start analyzing my data to some good extent, and that's really comes from working with the ability to pull data into R, which is coming directly from a Hadoop cluster. And you can start doing really some crazy stuff from R.
Thanks for watching our videos.
And be sure to subscribe, and if you like the video, feel free to hit that smash button and tell it to your friends.
That's all.
Yeah.